Okay, so here we go with the similarity solutions. In our first question, we see similar triangles, and we have to be able to recognize this situation as being similar triangles. The parallel lines, making a cross in the middle over here, are what we need to be able to spot. Now, triangle ABX is similar to triangle DCX, is what we need to know walking into this question. So that's our first mark for completing that statement. We're then asked to calculate AX. Now in similar triangles, we can work out a scale factor between corresponding sides. Here on the smaller triangle we've got a side of 4, which clearly corresponds to the side of 8 on the larger triangle. And it's pretty straightforward to see that the scale factor must be 2. That means multiplying lengths on the smaller triangle by 2 will give me lengths on the larger triangle. So now the question is, which length corresponds to x on the larger triangle? It's quite tempted to say this one does, but in fact it's this one over here. Imagine if the smaller triangle was rotated down around into this larger triangle over here. The side that would line up would be the 2.8 with the x, and the 2 centimeter side would line up with this side over here. So if I take the 2.8 centimeter side and multiply it by 2, I'm going to get x. So AX is equal to 2.8 times 2, which is 5.6 centimeters. Now, in the next part of the question, we're being asked to find the area of triangle DCX, the smaller triangle, given that the area of the triangle ABX is y. So, up here, we are told the area of this triangle is y. Now, in order to get an area scale factor, we have to square our length scale factor. So over here I said the scale factor was 2, but what I really meant was the length scale factor was 2. That means the area scale factor is 2 squared, which is 4. And if it was a 3D shape, the volume scale factor would be 2 cubed, which is 8. Clearly I don't need a volume scale factor in this question. So if I want to multiply if I have an area on the smaller shape and I multiply it by 4, I'll get an area on the larger shape. This means to get the area of the smaller shape from the larger shape, I must divide by 4. So this area is y over 4. You could of course express this as 0.25y or whatever you want. A quarter y is also fine. Let's have a look at the next question. Two bottles and their labels are mathematically similar. The smaller bottle contains 0.512 litres of water and has a label with an area of 96 square centimetres. The larger bottle contains 1 litre of water. Now litres are units of volume, so I'm being given information about volume when they talk about litres. I want to calculate the area of the larger label. Now this one is quite tricky. We need to think about this relationship that we talked about before between length scale factor, area scale factor, and volume scale factor. And essentially whatever information they give me is going to give me either a length, area, or volume scale factor. I want to manipulate that information into the scale factor that I want. So from the smaller bottle to the larger bottle, I'm getting a volume scale factor that I can work out. If I do 0.512 divided by 1, I'm getting the volume scale factor from the smaller one, from the larger one, to the smaller one. From large to small. Because this is a decimal, if I multiply by something 0 point, I'm going to get something smaller. So if I take the volume of the larger one, multiply it by 0.512, I get the volume of the smaller one. If I did this division the other way around and went 1 divided by 0.512, I'd get the volume scale factor from the small bottle to the large bottle. Now, I'm asked to work out the area of the larger label, knowing the area of the smaller label. I can't get an area scale factor without first getting a length scale factor. So I'm going to cube root my 0.512 in order to get a length scale factor. I'm just reversing this idea that cubing a length scale factor gives me a volume scale factor. So if I cube root 0.512, I'm getting 0.8. To get an area scale factor now, I have to square that 0.8, getting 0.64. Remember, this is taking something on the large bottle, multiplying by 0.64 to get an area on the small bottle. Now I know the small bottle has an area of 96 square centimeters. I don't want to times this by 0.64 or it will get smaller too. To go from the small bottle to the large bottle, I must divide by this scale factor. So I've got 96 divided by 0.64 to do. And that's getting me 150 centimeters squared. So this question is quite tricky, and it might take a little bit of thought before you fully understand what's going on. They're going to compare for me two measurements, either lengths, areas, or volumes. That's going to give me either a length, area, or volume scale factor, and in this question, we're getting a volume scale factor. In order to get an area scale factor, I need to first of all work out the length scale factor by cube rooting the volume scale factor. Squaring the length scale factor will give me the area scale factor, and I use that to calculate the missing area. Just be very careful to imagine whether we're going from small to large or large to small. It's either going to be a multiplication or a division, and if your answer clearly doesn't make sense, you pick the wrong one, and it's a simple matter to do it the other way around. So now that we've dealt with those first two questions, the rest of the solutions will appear in the next video.